everyone, welcome to the channel Knowledge of. Friends, subscribe to the channel and click the bell icon for the latest update. Today we're going to start with the software engineering class, and this is your class 5. As we had discussed your class 4 where we had completed unit 1 and unit 2, and this is the unit 3, which is your software design that we have to start with it. And this is the first class of software design. This is of unit 3, which we have to discuss here. Before starting with this, it's a huge request from my side to all the viewers. Please go through with the subscribe button and please like, share and subscribe our channel so that many in maximum people can get the information at once, and even you can also enjoy the video as well. In unit 3rd, which will start discussing about the software design, where we have to start with the basic concepts of software design here. The first question that they had asked you in terms of it, that what is software design? Explain the characteristics of good design here. So in that, so software design, or we can say that the characteristics of the good design. The first we'll discuss about the good software design, which is the definitions of software design here in this. That is, the software design is the model of the software which translate the requirement into the finished software product, and which the details about the software data structure, architecture and interfaces, and led to the components that are necessary to implement the systems that are given here. In terms of characteristics and the design, the good characteristics of a good design here. In this, the first characteristics we have that the good design should implement all the requirements that are explicitly mentioned in the analysis model, and it should be accommodate that all the implicit requirements demanded by the customers here. The second characteristics we have that the design should be simple enough so that the code developer, code tester, as well as those who are supporting the software will find it readable and understandable. The third characteristics of the software design we have, which is that the design should be comprehensive, and that means that it should provide a complete picture of software addressing the data, functional and behavioral domain from an implementation perspective as well. Now we'll go ahead to discuss the low-level design, which is comes under the modularization here. In terms of it, we have to discuss the concept of modularity. In concepts of modularity, this has been asked for 2 times in the examination paper of 2 marks each here. In all times here that they had asked you, so that in that same cases, the modularity is a technique in which the software is divided into the separately named and addressable components that are called modules, and the big and the complex problem is broken down into small problems, and the solutions for such sub-problem is obtained independently as well. In terms of it, now we'll discuss, write a short note on coupling and cohesions. As you can see here, in coupling and cohesion, where this has been asked 1 time in 4 marks and 1 time of 5 marks. So that is also an important one, because that 4 marks and 5 marks is all total is 9 marks, but they had asked you in multiple time in the examination paper, so that is also plays an important role as well. So that what we have to consider about it. First we'll discuss about the cohesion here. In terms of cohesion, that in a cohesion, that the cohesive module performs only the task in the procedure with a little interactions with other module, and that is the reason when we are going in the respective towards the cohesion here, which is the modules that only one task in a processor with little integration with other modules as well, with the same that one module, and that the high cohesion is considered to be a good in software design. With cohesion, that data binding is done. But in terms of coupling here, that the coupling is a measures of interconnections among the modules in a program structure. The low coupling is considered to be a good in software design. With coupling, interface complexity is decided here. Now we'll go ahead with the other questions that what we have to discuss here, and in the same cases, that is that the question has been asked is what do you understand by a design concept of cohesions and measures, and that briefly explain each level of cohesions and also compare with the coupling measures as well. This has been asked in 1 time of 10 marks and 1 time of 5 marks as well. The other question is, What do you mean by the term cohesion and coupling in a context of software design, and how are these concepts useful in arriving at a good design of a system? So this has also been asked for three times in the examination paper of 10 marks. So they had already total asked you 10 marks, 40 marks of each, and 5 marks in one. And that is define the term software design and also discuss the coupling in the context of the software design for a good design that the modules show have should have a low coupling, and why this has been asked for 10 times in the exam, 10 marks of each year, so that they had asked you about it. So in all total you can say that so 55 marks they had asked you in different examination paper. So we'll talk about the different types of cohesions here. So the different types of cohesions, as I told you about, the first is coincidentally cohesive, and the second is geologically cohesive, third is temporal cohesive, procedural cohesion, communication cohesive, and data coupling as well. In the data coupling, this has been the data coupling and the control coupling and the common coupling we have. These content coupling, these are the parts of the communication cohesive. Now we'll discuss these things in the detail here. For terms of the coincidentally coincidentally cohesive, that the modules in which the set of the set of tasks that are related with each other loosely, and then such modules are called coincidentally cohesive. And for the second one, we have for the logically cohesive here, a module that perform the task that and the logically related with each other is called logically cohesive. For the temporal cohesive here, the cohesion here, that is that the module in which the task need to be executed in some specific time span is called temporal cohesive. The other we have is your procedural cohesive here. In a procedural cohesion, that is when processing elements of the module are related with one another and must be executed in some specific order, then such module is called procedural cohesive. The other we have is the communicational cohesion. This, when the processing elements of the module share the data, then such module is communicational cohesive here. That is being divided into here, that is your data cohesive. In this, that the data coupling is possible by the parameter passing or data interaction. The second we have is your data coupling. In the data coupling we have your, there is a type of, you can see here, this is being divided into two, this is being divided into one, and this is being divided into two. This is divided into bin is the control flag, and this is whole is your coupling control coupling. This is your data coupling. It is your the data variable, and that has been divided and connected to the global data, and this is all known as under coupling here. So the data coupling we had understood. The second we have is your, that is your control coupling. In this, that the module share related control data in a control coupling as well. The other we have is your common coupling, that we have to talk about it, which is in common coupling, the common data or the global data is shared among the modules. And the other we have is your content coupling. In this, the content coupling occurs when one module makes use of the data or control information that maintained in another module here. Now in terms of it, the other question that they had asked you in terms of it to differentiate between the cohesions and coupling here. So we'll discuss the difference between cohesions and coupling. In a cohesion here, that in cohesion the cohesive module performs only one thing. In coupling here, that the coupling represents how the modules are connected with other module or with the outside world. In cohesion here, that is with cohesion the data binding can be done, but in coupling here, that is with coupling the interface complexity is divided. In cohesion, the goal of the cohesion is to achieve high cohesion, and in coupling the goal of the coupling is to achieve lowest coupling. In cohesion, that the various types of cohesions are like coincidental cohesion, logical cohesion, temporal cohesion, procedural cohesion, and communicational cohesion there. In coupling, that is the various types of couplings are data coupling, control coupling, common coupling, and that is your content coupling as well. That is the comes under in it here, that what we have to discuss here. Now we'll talk about the another question, that is the another different question has been asked here, which is the question is as to be follows. That is, what do you mean by functional independencies, and why functional independencies is the key factor for the good software design? Explain. This has been asked of 10 marks here. In this, in terms of it, that the functional independencies here, the functional independencies can be achieved by developing the functional modules with a single-minded approach. By using the functional independencies, the functions may be compartmentalized and interfaces are simplified. Independent modules are easier to maintain with reduced error propagation. Functional independencies is the key to good design, and a design is the key to the software quality. The major benefit of functional independencies is in achieving effective modularity as well. Now, in the same cases that we discuss moreover related to this, that is another question has been asked. This question has been asked for 10 marks. The question is in terms of functional dependencies only, that is to explain the following statement. The statement is that the degree of the coupling between the two modules depends upon their interface complexity, and that's what we have to explain it out. This is being asked of 10 marks here, so this is also an important one. This that the coupling effectively represent how the modules are connected with the module or with outside world, and that the low coupling means that the modules are loosely interconnected so that those modules are less dependent upon each other. High coupling means the modules are tightly coupled and that module is highly dependent upon other module. On the same cases here, that due to the high coupling, the changes made in one module has a great impact on the other module, and the degree of the coupling between the two modules depends upon the interface complexity as well. Now we'll go ahead with the further one, and that what we have will discuss about it, which is your architectural design. In terms of architectural design, that the question has been asked is write a short note on architectural design here. The question is on definition of architectural design we have. The architectural design is the design process for identifying the subsystem making up the system and framework for the subsystem control and communication. And the goal for these architectural design is to establish the overall structure of the software design, where the architectural design represents the link between the design specification and actual design process. In an architectural design, the logical system components and communities between items are identified. So here we'll discuss the activities in a design form, or we can say that the common activities in the design process. So we'll discuss about activities in, that is your common activities in the design process that we have. First we have is your system structuring, second is your control modeling, and the third we have is your modular decomposition. In a system that is structuring here, that the system is subdivided into the principal subsystems, components, and communication between these subsystems are identified. In a control modeling here, a model of control relationships between different parts of the system is established here. And for the modular decompositions as well, that the identified subsystems are decomposed into modules as well. Now we'll discuss another topic here, which is your software architecture. In the terms of it, we will go ahead with the question here. The question has been asked is that defines software architecture, explain why it may be necessary, design the system architecture before the specification written with a simple and that compare functions oriented and object oriented design as well. So first in the software architecture that we'll discuss, because the other question has been asked 4 times in the 10 marks question. Other question is write a short note on software architecture, that what we have to talk about it, which is of 5 marks. In terms of software architecture is a structure in which consists of various components externally visible, that we have the word properties of these components and interrelationship among these components as well. The other thing in terms of it, that the system architecture defines the role of hardware, software, people, face procedures and other system element as well. Designing of system feature will help the developer to understand the system as a whole. With the same case, we can say hence the system architecture must be built before specifications are completed. Now we'll go ahead with the difference between object oriented and that is your function oriented. In terms of object oriented, that we have for the object oriented, in an object oriented design method, the software design is designing object here. In the function oriented here, in a function oriented design method, the software design is by designing function only. The other will talk about it in terms of it, which is the another thing, and that is the another differences here. And that we go ahead, the other difference is your with the same case for the object oriented. In object oriented design, state information is shared among the object, and for the function oriented, in a function oriented design, that the state information is centrally located and several functions on this centralized data are defined. The third difference is in object oriented, that using this design approach, bugs can be easily located and corrected without affecting the other module. Wherein function that is oriented, the function oriented approach simple to design as well. For the other difference we have for this, for example, to design a railway reservation system, various classes should be used here, and in the same cases that we have here, which is in terms of like class passenger, then your attributes will be the names, age, sex, source and destination. Operations will be the get personal data, reservoir and cancel. Class, the another class will create, that is your ticket, and the attributes we have is your ticket ID, source, destination, date, fare amount as well. Operation is that to compute fare here. In terms of functional that is oriented, for example, in a railway reservation system, the major function will be get personal detailed like reserve, cancel or compute fare as well. We'll talk about the another one, which is on terms of structure chart. The question that is arise here, that is about the design structure chart, and the question has been arise, explain structure chart. This has been given as has been asked of 2 marks. In terms of structure chart here, that is the structure chart is the principal tool of structure design. The basic element in the structure chart is module, and a module defined as a collection of program statements with 4 attributes here. In the same cases, the 4 attributes that we have, which is the first we have is input and output. Here, what the module gets from the invoker is called input, and what the receiver gets from the module is called output. The second we have is function, that is the function processes the input and produces the output here. The third we have, that is your mechanism, that is your mechanics. Here, the code or the logic by which the function is carried out, and the other is your internal data, where it is the own workspace as well. I'll talk about another one which is related to the pseudocode here, that is explain pseudocode. In terms of it, this has been asked of 2 marks. As the first we'll talk about it, that is the pseudocode is the combinations of algorithm written in a simple language and programming language statement here. In the same cases, this code is effective building block for actual program. For example, if you want to find out smallest number among 3 variables, then the pseudocode can be written as, the first step for this we have is you read values of a, b and c variables. If a is less than b, if a is less than c, then print a is small, else print c is small, else if b is less than c, then you have to print c, b is small, else print c is small here. That will be the further pseudocode here. Now we'll go ahead to discuss about the flow chart. That is also an important one, and that is also we have to go ahead. Now we'll talk about the flow chart here. The question has been arised, what is flow chart? How is the flow charting technique useful for the software development? This has been asked of 2 times in the examination paper of 5 marks. That will talk about it. The flowchart is a graphical representation of an algorithm. With the help of the various symbols, the logical flow is given in the flowchart. Flowchart helps in understanding the program, and it is not written on a computer for execution as well. For the other case, we'll talk about it. For example, here, suppose we want to check the smallest number among the variable, then algorithm that can be written is to be as follows. The first step we have to start with it. Then after that, read the values for a and b and c as well. Then if a is less than, then go to go to the step 4. Otherwise, go to the step 5. Less than b. Then if a is less than c, then print the message that a is the smallest. Otherwise, the message is the c is the smallest. Other, if a is less than c, then print the message b is the smallest, otherwise print message c is smallest, and then you have to stop. The flow chart for this we have been given here, that is first we have to start with it. Then we have to read the values for a, b and c. Then if a is less than b, then of course if it is yes, then you have to go ahead, which if a is less than c. If it is no, then if b is less than c. If it is yes, then b is the smallest, and if b is less than c is no, that is false, that is c is the smallest here. In the same case, if it is true, then if a is less than c, and if it is no, then c is the smallest here. If it is c is the smallest, if a is less than c, if it is yes, then a is the smallest. So here c is smallest, b is, that is we have c smallest, that all comes under in it, and if it is b is smallest, then we'll have to stop here, as you can see here. Now we'll go ahead further to talk about in this only, that is about the design strategies. And in the term of design strategies, explain the following with the term with an example, that what we have to talk about it. The first we have is your functional oriented design, and that is we'll talk about, this has been asked for 10 marks. So they had asked you about the functional oriented design here. Then after that they had asked you about object oriented design, and the other we have is your top down and bottom up design as well. So that we'll discuss here in the detail. For the functional oriented design here, that is in functional oriented design, that the design that design of the software system is divided into various interacting units. Each unit then becomes a function. The system is designed from functional point of view. This approach is more used for developing the smaller system, but not preferred for larger system, because it is difficult to know what larger system do. The various models that can be created in functions oriented design here. The first is data flow diagram, the second is the structure charts, and the third is the pseudocode here. Now we'll talk about the object oriented that is design here. In this,
In object-oriented programming, that approach, there is a collections of objects. Each object consists of corresponding the data structures here, that we have, and the required operation like procedures. The various characteristics of the object-oriented programming languages are: the first we have data encapsulation, inheritance, polymorphism, and message passing as well. The talk about the top-down design. In top-down design strategies, the major modules of the systems are identified and decomposed into low-level modules, and this process is iterated until the desired level of the detail is achieved. In the top-down design, a stepwise refinement is done. In this method, the design procedure starts by creating abstract design. At each step that the design is refined is more detailed, and that until we reach a level where no refinement is possible and the design could be directly translated to code as well. In the same case, we will be going ahead further, and that what we have to talk about it as well. As you can see, for this we have for the top down, that has been divided here, as you can see here. This has been divided into 3. This has been further divided into 2. It is as follows, and this is connected towards it, and this is connected towards it that we have. This is for the top down. This is also connected to this as well, which is known as the top down design here. For the other one, we have bottom up design. In this, the bottom up design, which we talk about it. In this design strategies, we combine modules to produce a larger module, and then these larger modules are combined together to form even larger modules, and so on, and finally a single desired whole program. This design approach is asked to be as follows. As you can see here, this has been divided into 2. Then further they had been divided into many, and then they are further divided into many as well. This is a bottom up design. Since the design is progressed from the bottom layer upward, method is called bottom up design here. Now we'll go ahead with the other question, that what we have to talk about it. So that is, another question is to describe major weakness of the function oriented, that give a complete overview of the function oriented design and notations diagram. This has been asked of 10 marks here. We'll talk about the major weakness of the functional oriented design. For this, we have the major weakness of the functional oriented design is: the first is it is less efficient. Second is the implementation of this type of design consume a large number of time and memory. It is not suitable design method for commercial, that the commercial we have, that is the commercial software development as well, and for the design that we had discussed as well here. Other we'll talk about which is your, in terms of the notations that we have to talk about it. So that is, we'll talk about the UME notations here, and that is the user, okay, that we will talk about it, the use case diagram notations here as well. But before that, we'll discuss the UME full form is Unified Modeling Language. That is the notations, and that is present the object oriented design as well. The various diagram used for UML are: first we have here unified, this is the full form is Unified Modeling Languages. The first we have is your use case diagram. The second we have is your class diagram. Third is your state transition diagram, and the fourth we have is your sequence diagram. In the same case, we will talk about the use case diagram first here. In this is the use case diagram that represent the overall scenario of the system, and a scenario is nothing but a sequence of steps describing an interaction between a user and a system. For example, in library, student searches the books in catalog, find book, reserves the book, and he returns a book or pay fine for the book. All these activities constitutes a scenario. This is for the use case diagram for the library management system here. Now we'll talk about the another one, that what we have to talk about it, which is the another question, that is for the class diagram here, that we'll talk about it. The class diagram in the UML that are used to capture that the static view of the system. Basically, the class diagram represents how to put various objects together. The class diagram gives an overview of the system in which the various classes of relationship among these classes is represented as well. The another we have is your use case that we have talk about it, which is your sequence diagram. We'll talk about it in the same case for the sequence diagram that we talk about, and then the state transition diagram as well. For the that the sequence diagram we are talking about, where in the sequence diagram we have that is your in the sequence diagram we'll talk about later, but we'll talk about state transition diagram here. So in the state transition diagram that are used to graphically represent the states of the system during the processing, the object change their states in response to events, and this can be modeled by the state diagram. The state chart diagram are dynamic models as well. The first we have, this is the sign of initial state, which is in this that we'll talk about the descriptions as well, that it indicates the starting state of the system. This is the final state, which is this is the spatial state indicating the end of the activity. This is the another one, which is simple state, here state with no substructures. And this is the another one, which is a composite state, where here it is a state which occurs with two or more concurrent states with one active state of that at time in a composite state as well. Now we'll talk about the sequence diagram here. In the same case for the sequence diagram, that the sequence diagram, in this sequence diagram how the object interacts with the other object is shown, and there are the sequence of events that are represented by the sequence diagram, and it is time oriented view of the interaction between objects to accomplish a behavioral goal of the system as well. So various notations used in the sequence diagram that we'll talk about it, and that we have as follows as well. Let's go ahead with that as well. Here we have talked about the sequence diagram here. This is the first sign, where that is the user who is responsible for activating the various events. This is the another one, which is an active object who takes part in the various operation. This is the third one, which is the dotted line here. It represents a lifeline, that is a time span of the object. This is the another one, which is an active procedures on which an object is active. This is an arrow, where to interact two objects this kind of association is shown, along with the association the message is given. And this is the another one, which is the destructions of object as well. Now we'll talk about the other one that we have to talk about it, which is the another question here, and that is discuss the bottom up and top down design approaches with example. This is being asked here, and that is the another one is your 5 marks, which we had discussed. The other question is write short notes on object oriented design, which is of 5 marks. The another question is define the following terms like object, message, abstraction, class, inheritance, and polymorphism as well, so that we talk about it. And for the object here, in terms of object, the object is an instance of class, the class variable that called object here. Using object we can access the member variable and member function of a class. Object represent a person, place, or any item that the program handles. For example, if the class is country, then the objects can be India, China, Japan, USA, and so on. I'll talk about the message here. In terms of message, in the object oriented programming, any two objects communicate with each other using the method, and this is called message passing mechanism. Where next is your abstraction, and the abstractions means representing only the essential features that by hiding all the implementation detail in the class is an entity used for the data abstraction purpose as well. For the class here, that is a class can be defined as an entity in which the data and functions are put together. The concept of the class is similar to the concept of structure in C, and a class is declared by using the keyword class as well. Now we'll talk about the another one here, So with the same case for the abstraction that was discussed, we are going to discuss for the abstraction here. In this, the abstraction means representing only the essential feature by hiding all the implementation detail. In the class is an entity used for the data abstraction purpose as well. The other we talk about it, which is about the class here, that a class can be defined as an entity in which a data and a functions are put together. The concept of class is similar to the concept of structure in C, and a class is declared by using the keyword class as well. So with the same case, now we'll discuss about another one, that is the inheritance here, and that we will discuss here. But with this same cases, that is for the inheritance, that inheritance is the property by which the new classes are created, and using the old classes. In the other words, the new classes can be developed using some of the properties of the old classes as well. Inheritance support hierarchical structure as well. We'll talk about the polymorphism here, and that is another one. Polymorphism is the ability to take more than one form of and refer to an operation existing different behavior in different instance, that is situation here that we talk about it. Now we'll go ahead with other question that we have to discuss here, which is that is the advantages of using object oriented approach and disadvantages as well. For the advantages that we are going to discuss here, to discuss the main advantages of using an object oriented approach for the software design, that has been asked of 10 marks. In the terms of advantages, using an object oriented programming is a complex system that can be partitioned into a small modules as well. Another advantages is that the error can be identified easily. The third we have, even if one module is modified to some extent, another module remain unperfected. The fourth is that the maintenance cost can be reduced by adopting an object oriented programming for developing a system. The fifth is that the one component can be reused in same system or another, and this process is called reusability. The reusability reduces the overall cost of developing the system as well. Now we'll discuss about the another one, and that is we have to discuss about the question that we have that has been that is we'll go ahead, and that is another question is to discuss the advantages and disadvantages as far as distributability is concerned of the data flow model and the object model with an example. This has been asked of 10 marks, and that is the disadvantages we talk about it. The system development process is slow. The object oriented programming is complex to implement because every entity in it is an object here, and that is we'll go ahead with the other one, and that is the another disadvantages we have, that is you can see that the third disadvantages, if some of the numbers that are declared as private, then of course that about the members here, those members are not accessible by the objects of another class. And in object oriented programming, everything must be arranged that the forms of class and modules, and for the lower level application it is not desirable feature as well. Now we'll talk about the other question that we will discuss here, that is in the terms of it, that is another question, which is the software measurement and matrices. So software measures measure and software metrics here. Differentiate between a software measure and a software metric, we talk about it. This has been asked for 2 times of 2 marks and 2 times of 5 marks here, that we have to talk about it. And that is in the same cases we'll go ahead, and that we talk about it, which is the another one is the software measure. In this term, it is in quantitative indications of the extent among dimensions or sizes of some attribute or of a product or process. In the metrics we talk about it, that is it is in a degree to which a system, component or the process or possesses a given attribute. The software metrics relate several measures, for example an average number of an error found per review as well. We'll talk about another one, we'll talk about it, and that is the another question that has been asked here, and that we'll talk about it as I told you. In the same case that with reference towards it, and the question is we have is to define the software matrix. What are the various categories of software matrix? Discuss with the help of an example. Other question is we talk about here in the same cases that the question is write a short note on software matrix here. That we'll talk about it. That is the another one, and which is the another question is write a short note on software matrices. This has been asked of two times, one times in the 10 marks question paper, one times 5 marks. The other question that they had asked you. So that is about we had discussed here the software measures and matrices. Now we'll discuss the types of matrices here. In the types of matrices, the first type we have is your direct that is matrix here, and that we talk about it. In the same case for the direct matrix here, it refers to the immediately measurable attribute, for example the line of code and the execution speed. The other we have is your indirect matrices. It is referred to the aspects the aspect that are not immediately quantifiable or measurable. For example, that is the functionality of the program here, and that we'll talk about it. And in the same cases, we'll go ahead with other question as well, and that is in the terms of the size oriented measure. In the size oriented measure, the size we'll talk about it. That is the question we have is what is the size oriented measure, give its advantages and disadvantages as well, and that we talk about it. In the size oriented measures here, that is the size oriented measure is derived by considering the size software that has been produced, and a simple set of size measures that can be developed is to be as given here. That is we'll go ahead, and that is we're talking about the size here. In the same case for the size here, that is the kilo lines of code, which is KLOC. Another is effort, which is your person per month. The third we have is your productivity, which is KLOC, and which is about the person month, and quality, which is your number of families per KLOC, and fault number of faults per KLOC, and the cost is your dollar per KLOC as well. The documentation is the pages of documentations and per KLOC here. I will talk about in the same cases here. Now in the same cases we'll talk about it, where the size measures is based on the that is line of code computation, and the lines of code is defined as one line of text in a source file. The advantages we'll talk about it here, that is the artifacts of software development, which is easily counted. The many existing method use log as a key input. The third advantages is the large body of literatures and the data based on log already exist here. So we'll talk about it. The another one in here, that is we talk about it, and in the same cases that I had gone with disadvantages as well, that this measures is dependent upon the programming languages. This method is well defined, but shorter program may get support, and it does not accommodate non-procedural language, and it in early stage of development it is difficult to that estimates the LOC as well. Now we'll discuss about another one that we have to discuss, as you can see, is your Halstead software, that is your science that we talk about it, and that is the another question, which is in the Halstead software science. This has been asked of 5 marks. So the Halstead complexity measurement was developed to measure a program module complexity directly from the source code, and with emphasis on the computation complexity. The Halstead measures are based on the 4 scalar members derived directly from a program source code, and that is we have as follows here. In the same cases, we have your N1 here, which is the N1 in talking about. N1 is the number of the distinct operators. The N2 is the distinct operands. Capital N1 is the total number of operators, and a capital N2 is the total number of operands as well. Now we'll discuss about the table here, that what we have to go ahead, and that is also an important one here. and that is that we go ahead. In the same cases, we will be going ahead, and that is the another one, that from these members the 5 measures are derived, and that is here we have your program length, program vocabulary, volume, difficulty and effort. In program length, that has been denoted by capital N, which is n equals to n1 plus n2. Program vocabulary is small n, that is n equals to n1 plus n2. For the volume, capital V, which is volume equals to n abstract log 2n. Difficulty we have is D, capital D, that is D equals to n1 upon 2 abstract capital N2 upon 2 by 2 as well. Effort we have capital A, that is E equals to D abstract V here. Now we'll go ahead with the question that what we have to discuss as well. As you can see here, in the same cases, the question is for the following C program, estimate the Halstead length and volume measures of size with LOC measures. And the program we have, as I written here, that is the program to calculate the GCD to numbers, which is int compute GCD x comma y, while x naught is equals to y, and that is if x is greater than y, then x equals to x minus y, else y equals to y minus x, and that return x and then closing tag, and that this has been asked for 10 marks, so that will solve it out here as well. Let's go ahead to solve it. In the same cases, the operands and the occurrence we have an operands and occurrence as well. The int occurs 1, and that is small bracket occurs 3, curly bracket is 1 here, and that is the comma we have 1, while is 1, if is 1, and then is 1, unequal is 2. Where this is also been 1, and that is the minus sign has been 2, greater than 1, else is 1, return 1, compute grade 1, and GCD 1, and that is x is 7 and y is 6, and colon is 3 as well. Now we'll go ahead with other question that we have to talk about it, which is in the same case that we have given here is 14, and that is the n1 is 20 and n2 is 3 and n2 is 14 here. For that, n equals to n1 plus n2 and small n equals to n1 plus n2, and the capital N is 20 plus 14, which is equals to 34, and capital small n is 14 plus 3 is equals to 17. The length equals to n1 log n, n1 plus n2 log n2, 14 log 14 and 3 log 3. So 14, that is your abstract 3.80 plus that we have that is your 3 into 12.58, and that is equals to is your 53.30 plus 4.75, that is equals to 58. That will be the right answer here. And for the another one that we'll talk about it, which is the another one in the case of the volume here, and that is the n log n, and that is your 34 log 17. In the same cases, that is 34 log that will put the value, and that is 4.08 of log 17, which is equals to 139, and that will be the right answer for this question as well. Now we will be going ahead with a further question that we have to talk about it, and that is the another one. And in the same cases, we will be going ahead to discuss that we have as follows. Let's go ahead with the question other one. Next we'll go ahead with other question that what we have to talk about it. That is, the question is what do you understand by the token count, and consider a program for having, and that they had given you the question here, which is for number of distinct operator equals to 12,
that is the another we have, which is in terms of it, that is your the number of operands equals to 5, that is total number of operator occurrence (20), and the other we have total number of operand occurrence equals to 15. So we have to calculate the different Halstead software metrics for the above program. This has been asked of 10 here, and that is we have to talk about it. Now we'll go ahead. Next we'll go ahead, and that is the another we have to talk about it, which is in the terms of it we have to calculate the different Halstead software matrix for the above program. And the other question we have, using a suitable example, explain how Halstead software science is used to measure the size, development effort and development cost of the software product here. And that is this has been asked of 10 marks as well. In the same cases, for the given that we have here n1 equals to 12, n2 equals to 5, capital N1 equals to 20, and n2 equals to 15 here. In the same cases that we have to go ahead, and which is the program length n equals to n1 plus n2, which is equals to 20 plus 15, and that is equals to 35. For the another part we'll find it out here as well, and that is for the another. So for the another question, that which for the second part that we have is your program vocabulary, and that is equals to n1 plus n2 equals to 12 plus 5, and which is equals to 17. The third we have program volume V equals to n log 2n here, which we have to talk about it, and that is equals to 35 abstract log 2 17, and that is equals to 35 abstract 4.08, and we'll find out the answer, which is your 142.8. Now we'll talk about it, the another one, which is the fourth one, which we have to talk about it, that is your length estimation. And for that we have your n1 log 2 n1 plus n2 log 2 n2, and that is we talk about it here. The another one here, and that is this is for the another one, which we have to talk about it, n2 log n2, and that is equals to 12 log 2 12 plus 5 log 2 5, that is equals to 12 abstract 3.58 plus 5 into abstract 2.32, which is equals to 42.96 plus 11.6, and that is equals to this 54.56. that will be having as an answer, sorry, 11 that is 54.56, that will be the answer here. So now we will be that we have to talk about it for the another one. So now we'll again understand as well, and for the another one which we have to talk about it, which we will continue in the next coming class for sure. And other than that, we will discuss about more on the detailed about with the another topic, which we will talk about it, which is the function point based measures as well, and in reference towards this has also been asked in many times in the examination paper as well, so that we discussed about it. And first of all, it's a huge request from my side to all the viewers to please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. And that is now we'll go ahead with other one, and that is the another respective in terms of other than this software engineering, if I'm talking about,
We are dealing with the quantitative aptitude, and there we had started with the arithmetical ability, where we had done the operations on numbers as well as the LCM and SCF of the numbers, as well as decimal fraction, and we are dealing with the simplification as well. After that, we're dealing with the chemistry for the class 12, which is useful for the academics as well as for the competition as well. For that NCRT we are dealing with. Other than that, we are dealing with the reasoning here. Here we had completed the verbal reasoning, and that is that we have to discuss, that is your reasoning. We are dealing with verbal reasoning, which we had completed. It's include the general mental ability and the logic reasoning. Other we have is non-verbal reasoning, which is a series, that analogy, and then we had started with classification. Hopefully we'll complete that as well soon. And other than that, if I'm talking about, we are dealing with the software engineering. In software engineering, we had completed unit 1 and unit 2, and we had started with unit 3 as well, and surely in the next coming class we will end up with as well. So in unit 1 that we have here, where we had completed the introduction to the software engineering, software component, software characteristics, software crisis, and that we have to talk about. That is we talk about it, and that we have to talk about, as I told you. And in the same cases, the introduction to the software engineering, software component, software characteristics, software crisis, software engineering process, similarity and differences from the conventional engineering process, software quality attributes, software development life cycle, SDLC models, waterfall model, prototype model, spiral model, evolutionary model, development model, iterative enhancement model. The second unit we have is the software requirement specification, which is SRS. There we have to discuss about the requirement engineering process, elicitation, analysis, documentation, reviews, and management of the user needs, feasibility study, information modeling, data flow diagram, entity relationship diagram, decision tables, SRS document, IEEE standards for SRS as well. The software quality assurance, we have to talk about the verification and validation, SQA plans for that is software quality framework, ISO 9000 model, and SEI CMM model as well. Now we'll go ahead with the other one we have. The other we talk about it, which is the software design. Basic concept of software design, that we talk about it, which is the architectural design, low level design, modularization, design structures, charts, pseudocode, flowcharts, coupling and cohesion measures, design strategies, function oriented design, object oriented design, top down bottom up design, software measurements and matrices, various size oriented measures, Halstead software science, functions point based measures, cyclometric complexity measures, and control flow graphs as well. In terms of unit 4, which we have to discuss here, that is the software testing as well, and in the same cases, testing objectives, unit testing, integration testing, acceptance testing, regression testing, testing for the functionality, and the testing for the performance, top down bottom up testing strategies, test drivers and test stops, structural testing, white box testing, functional testing, black box testing, test data suite preparations, alpha and beta testing of the product, static testing, that strategies, and a formal technical reviews, peers reviews, walkthrough, code inspections, compliances with the design and coding standard as well. So with the same case, we have to discuss the unit 5 as well, that we have to discuss here. The another question we have to talk about it, there is another unit we have to talk about it, software maintenance and software product management. Software as an evolutionary entity, need for the maintenance, category of the maintenance, preventive, corrective, and prospective maintenance, cost of the maintenance, software re-engineering, reverse engineering, software configuration management activities, change control process, software versions control, and overview of the case tool, estimations of various parameters such as cost, effort, schedule, derivations, construct and cost models, which is your COCO model as well, and that is the resource allocation model, software risk analysis and management as well, and that is the level discussed here. And thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give your suggestion on a comment box as well, so that we have to end up with it. And you can just please go through with the subscribe button if you had not yet gone through with that. Please, it's a huge request to go and subscribe our channel. Thank you, and thanks for appreciation for all those subscribers, those who have done it. Thank you, and please like, share, and subscribe to our channel.